Hi everyone, I welcome you all in the quick solutions discussion of All India AIATS Test Series Medical 2020. And we are discussing here test number 8, code C and D. And here's the chemistry section with the very first question, that's question number 61. The correct set of 4 quantum numbers for the valence electron of potassium atom is, if we talk about potassium atom, atomic number is 19. And let's write the electronic configuration to obtain the quantum numbers for the valence electron. So the configuration is 1s2, 2s2, 2p6, 3s2, 3p6 and the 19th electron or the valence electron 4s1. We know that this valence electron is present in the 4th shell. It means the n value becomes 4 for this case. What would be the value of L? The L value is 0 to n minus 1, we know that. And in this case, if you're talking about the s orbital, because valence electron is present in s orbital, that's why this L value is 0. Now, the turn for M, L value, magnetic quantum number. This is minus 1 to plus L. So, this becomes 0 also because L value is 0. And after that, spin quantum number. That spin quantum number indicates the spin of the electron. Only one electron is there. That's why plus half would be the spin for this. It means this is the whole set of all 4 quantum numbers, and this is correctly given here in option 3 as you look here. That's why this option 3 becomes your correct answer. After that, we have to take next question. Question number 62. For the redox reaction, MnO4 negative plus H plus ion plus H2O2 to give you Mn2 plus H2O and O2. It means this is the redox reaction that's taking place in acidic medium. The correct coefficients of the given species for the balanced reaction are. It means first we need to balance this chemical reaction. We have this reaction and we need to just balance it. Let's find out the two half reactions. This is MnO4 negative is getting changed into Mn2 plus. This is a reduction half because the oxidation number of Mn is changing from plus 7 to plus 2. Now in this case, if we balance this in acidic medium, it gets changed into 4H2O. We have to add at this side, 8H plus ion at this side in the reduction half. Now we have to balance the charge also. So 7 positive charge at this side and 2 positive charges at this side. It means we need to just add 5 electron at this side. This is the first reaction, or simply the reduction half reaction. Now oxidation half reaction. Now in this case we have H2O2. It's getting changed into O2. Now let's balance the H plus ion first. Hydrogen is balanced now with the help of H plus ion. Now charge is 2 positive at this side. It means we need to add 2 electron at this side to balance the charge. The second equation we have. Now let's balance the number of electron. We need to just multiply 2 in equation 1 and 5 in equation 2. So ultimately the first equation becomes 10 electron, 16 H plus ion plus 2 MnO4 negative is getting changed into 2 Mn2 plus 8 H2O. Now if I talk about the second oxidation half reaction, it becomes 5H2O2 is giving you 5O2 plus 10 H plus ion plus 10 electron. It means we have both the half reaction and now 10 electrons can cut in this way. Now 16 H plus ion here, 10 H plus ion here. It means we are left with 6 H plus ion. Now water molecule 8 H2 at this side. So final equation that you will obtain here is 6 H plus ion plus 2 MnO4 negative plus 5 H2O2. This is the balanced chemical equation. Balanced redox reaction basically. 2 Mn2 plus 5O2 plus 8 H2O. Just have a look on the species given here. MnO4 negative 2. So this 2 is here in option 2 and 4. And now if I talk about the second species, what's that? This is H2O2. H2O2 5. So where is H2O2? This is here. And for this, it is 5 in option 2 as well as in option 4. Now let's check H2O. In case of H2O, we have 8 H2O molecules here. So 8 is given here in option 2. So which option becomes correct? Option 2 becomes correct for this question. After this, we need to just take next question. Question number 63. 18.9 gram of oxalic acid dihydrate. It means the formula of this oxalic acid becomes, because this is dihydrate, that's why this is oxalic acid dihydrate. With the help of this, we can find out its molar mass. It is dissolved in water to make final solution 500 ml. The volume of 0.2 molar NaOH solution required to completely neutralize 10 ml of oxalic acid solution. It means this is based on the titration process, and here we have the molarity of NaOH, and we need to just find out the volume of that NaOH which is required to neutralize 10 ml of this oxalic acid solution. So first we should know that whenever we talk about this process, milli equivalent of oxalic acid should be equal to the milli equivalent of NaOH for the process of neutralization. Now first let's find out the milli equivalent of oxalic acid. How we can find it out? We have 18.9 gram of oxalic acid. Find out its mole. Those would be mass divided by molar mass, and molar mass of this oxalic acid is 126 gram per mole. So these are the number of moles. Just divide it by 500 ml and then multiply 1000, because molarity we have. Now multiply n factor to it. So this is the normality, and now just multiply the volume that you are taking. 10 ml of this acid you are taking for the titration, for the neutralization process. It means the volume becomes 10 ml. These are the milli equivalents of oxalic acid. Now what would be the milli equivalents of NaOH? NaOH has the molarity 0.2. What is its n factor? That's 1. And what is its volume? Let's assume this is V. And this is equal to 0.2 V. These are the milli equivalents of NaOH. And what about the milli equivalents of this oxalic acid? If you calculate, you will find out that this is 6 milli equivalent. Now just compare these two. This 6 should be equal to 0.2 V. It means this V value is equals to 6 by 0.2. That is 30. So 30 ml volume of NaOH is required for the neutralization of 10 ml of oxalic acid. And yes, the correct answer would become option 2. Question number 64. The orbital angular momentum of 3D electron is. In this case, we should know orbital angular momentum. The formula that we use here is root L plus 1 and H cross. Now we're talking about the 3D electron. So for 3D we have, then the value of L is 2. In this way, the orbital angular momentum becomes 2 plus 1 H cross, and this is equal to 3 to the 6 root 6 H cross. Where this value is given, this value is correctly given here in option 2. So the answer for this question also becomes option 2. After that, there's another question. Question number 65. The most acidic compound among the following is. Let's check the compounds. First option we have phenol. Second one, acetylene or ethyne. Then methanol we have, and propene is here. Among all of these, we have alcohol and phenol as well as ethyne. Ethyne also shows some acidic nature by reacting with sodium metal. It has acidic proton in it. Similarly, if I talk about methanol, it can also show that. Phenol can also show acidic nature. But the maximum acidic nature is there with the phenol. Why? Because phenol, when loses one proton, it forms phenoxide ion. We know that. This is phenoxide ion. And this phenoxide ion is resonance stabilized. It means due to its resonance stabilization, phenol shows maximum acidic character, and resonance is not there with methanol. That's why its acidic nature is less as compared to phenol. So most acidic among all these is phenol. That's given in option 1.